In this video, we're going to look at something called rationalizing a denominator. Essentially, this is what happens. We have 2 over the square root of 3, and in math, we're not really supposed to leave the square root of 3 on the bottom. Now, as you get a little bit older and as you get into different levels of math, it becomes acceptable in some cases and not acceptable in others. I would relate it to this. While you're in high school in like Algebra 1, Algebra 2, classes like that, it's basically the same as leaving 6 over 12 as 6 over 12. Whereas you could reduce this to 1 over 2, and that's what your teachers typically want you to do. It's the same thing with this 2 over the square root of 3. So we want to rationalize this denominator, okay? And I'm going to do this on 2 different levels. There's, I guess, a basic level, and then there's a more difficult level. If you only need the basic level, only watch for that. If you need the entire thing, then just know I'm doing both levels. All right, so this video is also going to incorporate dividing radicals, which I've made a video over, and simplifying radicals, which I've made a video over. So be sure to check those out. If those help you or this video helps you, like, subscribe, comment, whatever you need to do. So when we are rationalizing a denominator, let's continue with this 2 over the square root 3 just to get the idea of how we do that. So what you're going to do is you're going to multiply the top, the numerator, and the bottom denominator by this square root 3. So whatever that square root is, that's what you're going to multiply the top and bottom by. All right, so we're going to multiply the top by the square root of 3 and the bottom by the square root of 3. Now, I'm going to show you a trick with this, but first let's do it fully. So 2 square root 3 would just combine to give me 2 square root 3, because this 2 can't really jump inside of this radical. All right, so we just multiplied 2 times an understood 1 here to get 2, and then the square root of 3 just carries over. All right, so now watch what happens on the bottom. When we do the square root of 3 times the square root of 3, I'm going to tell you the answer is going to be 3. All right, so here's the trick, and then I'll show you why the trick happens. When you multiply 2 square roots or 2 radicals that are the exact same underneath the radical, it ends up just giving you what's underneath the radical. Essentially, the radicals just drop. All right, now here's why. 3 times 3 is 9, but we're multiplying radicals, so we keep it underneath the square root. Now, what's the square root of 9? It's 3. And that's a pattern that will always happen. All right, so here's our answer. 2 radical 3 over 3. Now let's look at another one. And once again, I'm going to keep showing you this trick because I want to make your life easier and help you speed things up. Let's say we have, and I'll just try to come up with something. Let's say we have the square root, or let's say we have 3 over the square root of 6. Okay? Now, once again, we need to rationalize this, which means we need to take care of the square root on the bottom. We don't want it on the bottom. We want to rationalize it, which means we multiply the top and bottom by the square root of 6. All right? Now, 3 times the square root of 6 is just 3 square root 6 over. Now, we're multiplying here the square root of 6 times itself, the square root of 6. Now, the shortcut is when you do this, 6 is just going to be your answer. Essentially, the square roots drop. And here's once again the reason why. When I do the square root of 6 times the square root of 6, we get the square root of 36. And the square root of 36 is 6. Now, before you say this is our answer, we can actually reduce this further. This 3 is the coefficient of the square root of 6, which means it's being multiplied. And 6 is down here by itself, which means this 3 and 6 can actually reduce, which is, let's say that'd be 1/2. So this would give me the square root of 6 over 2, because we can act like there's an understood 1 here, and that's our 1/2. So this would actually be our answer. All right, so now let's make this more complicated. So let's dive in a little deeper. So let's say we have 3 over 2 square root 5. All right, now give this one a shot, see if you can figure it out. So once again, here's the issue. This square root of 5 on the bottom needs to go. So just because this 2 is here doesn't really change the process for us. All right, so essentially when you have one term on the bottom, the process is still going to be the same. We're going to multiply the top by the square root of 5 and the bottom by the square root of 5. All right, now that's going to give us 3 square root 5 over, now here's where you got to do a little bit of thinking. So this 2 we know is going to be multiplied by whatever we get when we do the square root of 5 times the square root of 5. So you could do this 2 ways. First of all, like I just said, there's a trick here. When you multiply a square root 5 by itself, you just get 5 as your answer. Essentially, the square roots go away. Or if you want to do it this way, it's fine. You can say 5 times 5 is 25. The square root of 25 is 5. All right, either way, we get 2 times 5, which is going to give me 10 on the bottom. So the part you have to pay attention to, which a lot of people just miss by mistake, is this 2 out in front. They'll end up writing this instead of 10. They'll say, well, this is 5 because I did the square root of 5 times the square root of 5, and they'll just leave out this 2 by accident. So my advice is to just go ahead and bring down this 2, or maybe circle it, do something to draw your eyes to it so you don't forget it. So then here's our answer. Because 3 over 10 can't reduce, so 3 radical 5 over 10 is our answer. All right, so that may seem simple enough. Let's look at one more example, and then we will go to some other problems that are more advanced, which once again, if you don't need the advanced problems, then you can just end the video where we are. All right, let's say we have the square root of 8 over 15. And from a previous video, we said, well, if we have a fraction under a square root, we can just divide 8 by 15, but here's the issue. 8 divided by 15 is not going to work. That won't divide. So you could do this a couple different ways, but here's the quickest way to get the job done. You can break this up and make it the square root of 8 over the square root of 15. Now, the square root of 15 is on the bottom, and we don't want it on the bottom, so we're going to rationalize this by square rooting 15 and multiplying it to the top and the bottom, which is going to give us, remember, when we multiply square roots, we multiply what's under the square root and leave it under a square root. 8 times 15 is 120, so we're going to leave that under our square root, over, now we have the square root of 15 times the square root of 15. Remember, the shortcut is this. Square root times a square root that's the exact same, just gets rid of the square roots, and we get 15 on the bottom. So now, a lot of people may say, okay, we're finished, but here's the issue. You can break down the square root of 120, and if we can break it down, we're supposed to break it down. So we could break this into a square root times a square root, and we need the biggest perfect square that divides 120, and that would be, let me check, I think it would be 4 and 30, actually. Yeah, because 30 does not have a perfect square other than 1 that divides it. So that seems a little odd, but this is actually how it's going to work out. So that's going to give us, let's see, 2 radical 30 over 15. And that's actually going to be our answer. Now, that looks a little odd, but 2 over 15 can't reduce. The square root of 30 can't be broken down any further. So that's actually where our problem is going to end. Now, in a previous video, we've done variables with radicals. You could actually get into the same thing here. Now, I'm not, for the sake of keeping this simple, I'm going to just let you work through some of that on your own. But this is where we're going to move from basic to more difficult problems. So let's do that. So now, what we're going to do now is something like this. And it may seem a little odd, but let's look at it. So first of all, let's say I have the square root of 8 minus the square root of 2 all over the square root of 2. Now, for some of you that may look a little odd, which it is pretty odd to look at. So here's what we have going on in the numerator. We have a square root of 8 minus the square root of 2. If you remember, when we add and subtract radicals, the 8 and the 2 have to be the exact same, or else these two radicals aren't like terms. So this is actually where we're, excuse me, where we're stuck. So once again, we have the square root of 2 on the bottom. We have to rationalize this. Now, what I would first of all do is put this top part in parentheses. So when we multiply, you can see we're actually going to have to distribute here, which seems really weird with square roots, but it's actually perfectly acceptable. What we're actually doing here is the square root of 2 times the square root of 8 minus the square root of 2. And we can actually distribute the square root 2 to the square root of 8 and to the square root of 2. All right, I know it seems weird, but sometimes math is a little weird. So the square root of 2 times the square root of 8 is going to give us the square root of 16 minus the square root of 4, which we know the square root of 4 is just 2. All right, once again, you can also see this pattern happens. A square root times the exact same square root equals 2, which is just the radicals dropping. All right, so now this is all over. Now we're going to do the square root of 2 times the square root of 2, which once again is just 2. Now, the only other thing we could do here, and hopefully you've already noticed this, I actually wasn't paying attention to it, the square root of 4, or square root of 16, is 4. So we can actually go ahead and reduce that and say 4 minus 2 over 2. And then the rest of this breaks down pretty nice, which gives us 2 over 2, which then just gives us 1. Now, not every single problem is going to work out that nice, but in this case it did. All right, so there's an example of a more complex problem. Now let's make it even more complex. So let's look at this situation. We have 4 over 4 plus the square root of 2. Now, here's the issue. This is a binomial, which basically means there's 2 terms. Okay? Anytime we have a plus or minus sign, it separates terms, so this is 2 terms. Now, when we have 2 terms, we can't do this, unfortunately. We can't just say the square root of 2 times the square root of 2 and do everything like we've normally done. Basically, when this becomes a binomial, it changes things, and it makes it to where we have to use something called a conjugate. Okay? Which if you've done complex numbers before, you've heard this. But essentially, here's the easy version of this. You just switch the sign of your binomial. So this is our 2-term binomial down here, 4 plus the square root of 2. If we flip that sign, it's going to become 4 minus the square root of 2. Now, that is what we actually use to multiply to the top and the bottom. All right, now once again, this is more complex, but I do want to make sure I cover it because I know there's some people that may need this. So let's continue. So we're going to multiply the conjugate on the top and the bottom. So let me rewrite all this. So we have 4 over 4 plus square root of 2. Once again, this is a binomial, so your job is really to know, hey, binomial on the bottom means I need to multiply by the conjugate, which is 4 minus the square root of 2 over 4 minus the square root of 2, and we're going to multiply. What I would make sure I do is put everything over here in parentheses and then put this in parentheses. Now on the top, we're just going to distribute. 4 times 4 is 16 minus 4 times the square root of 2 is 4 radical 2. All over. Now, we actually are supposed to FOIL this because they're 2 terms times 2 terms, which hopefully now we're pretty good at foiling. So we're going to do first, outer, inner, last, or you can do it if you know another method that way too. So we're going to say 4 times 4 is 16. Let's see, 4 times negative radical 2 would be negative 4 radical 2. And then radical 2 times 4 would be plus 4 radical 2. And then the square root of 2 times the square root of 2 is 2. But then we're going to have our minus sign because it's a positive times a negative. Now, notice what happens in the middle. The whole point of us multiplying by this conjugate is to make this part happen. Negative 4 radical 2 plus 4 radical 2 actually cancels. It would be like saying negative 4x plus 4x. It would give us 0x, which is just 0. And in this case, negative 4 plus 4 would give us 0 square root 2, which is just 0. All right, so we're left with 6 minus 2, or 16 minus 2, excuse me. So now, that should happen every single time when you multiply by this conjugate. That's why the conjugate is so useful. All right, so let's look. We've got 16 minus 4 radical 2. So we're going to multiply, or actually we're going to subtract this, but we can't. So we're just going to leave it exactly like it is. All right, now on the bottom, we're going to do 16 minus 2, which actually gives us 14. So now, let's look at what we have left. So some people would say, hey, here's our answer. We can actually go further, and I'll show you how. All right, so let's look at this. We have 16 minus 4 radical 2 all over 14. So I've done this in a previous video, I believe, but here's the quick version. This denominator, since this is subtraction, we can actually split this up into 16 over 4 minus 4 radical 2, or over 14, minus 4 radical 2 over 14. This denominator applies to the 16 and the 4 radical 2, and then we can just reduce. 16 over 14 would be 8 over 7, I believe, yeah. And then minus, let's see, 4 over 14 is 2 radical 2 over 7. So now you could do this, you could leave your answer like this, or you could actually put it back together. Since we have common denominators, you could put this back together and say 8 minus 2 radical 2 all over 7, and that would be your answer. Now, I may do, I'll go ahead and do one more quickly just to show you, but give this next one a shot. See if you can do this. Once again, this is more advanced for like Algebra 2, but if you're in anything like pre-calculus or anything like that, you will actually see this. So 6 minus the square root of 5. All right, so now let's check if we have a radical on the bottom, and we do. So now let's check, is it just one term on the bottom or is it two terms? And you can see there's two terms here and here. So now, what are we supposed to do? We're supposed to multiply by the conjugate, which means we change this minus sign to a plus sign. So 6 plus the square root of 5 on the top and the bottom. And once again, what I would do, put the two-term portions of this in parentheses. All right, so now we have 2 times 6, which is 12. 2 times the square root of 5, which is plus 2 radical 5. That's going to be on the top. Now remember, when we do this portion on the bottom, when we do this foiling on the bottom, we should end up with our square root 5 going away. Let's just make sure that happens. So we're going to foil this. 6 times 6 is 36 minus, or actually it'd be plus, plus 6 times the square root of 5, which is 6 square root 5. Then we're going to do negative radical 5 times 6, which is minus 6 radical 5. And then we've got negative radical 5 times itself, which is going to be minus 5. So if you notice, the middle part is going to go away. 6 radical 5 minus 6 radical 5 is 0. So we're left with 36 minus 5 on the bottom. We can say, okay, we've successfully gotten rid of this square root on the bottom. There's no longer a square root on the bottom. That should happen every time. Now let's just combine what we have on the bottom. 36 minus 5 is 31. 12 is not going to reduce with 31, neither is 2, so this is our answer. So once again, I know this video has some basic and complex problems mixed in together, but hopefully it helps you out. The trick is, once again, if you just have a normal, if you just have like 2 over the square root of 5, and there's one single square root, only one term, that's when you can multiply the top and bottom by the square root of 5. Okay, no tricks there. Now, if the bottom is a binomial, like let's say we had 1 plus the square root of 5, that's where we have to multiply by the conjugate, which is changing the sign in the middle, but we still multiply.